Hello everyone, my name is Artem Boyko. In this video, and with the help of an example, I'd like to show you how to use bundles of Revit on Dynamo in order to calculate working hours and working costs. In the construction industry, cost and time are the basis for all planning processes. All project participants in planning and processing are interested in cost and construction times. Everyone wants to know how long all this will take and how much it will cost. We will be working with Revit Dynamo. Revit is currently the best program for BIM modeling. But what does Revit offer us in terms of project management? Not much at the moment. But where is Dynamo? Dynamo is an add-on to Revit developed by open source community. Dynamo is a tool that allows you to work on all the data, objects and their properties in Autodesk Revit. This video is meant to show how to translate all building parts into volumes and convert these volumes into final cost and time calculations. To visualize this data, in our example, we will be using Microsoft Project. However, also other planning tools can be used here as well. Within Microsoft Project, we can present this data in form of Gantt charts or in form of Kanban. Let us shed some light on the matter. Using the example of a small project, we will consider both the assembly costs and assembly times of each process or building element. This can also be production costs and production times in the production phase, or planning costs and planning times in the planning phase. Let's take a closer look at this at the end. And now let's start. To simplify things, let's take the construction of a small hall as an example. Let's assume this hall is 30 meters long and 18 meters wide. Single a aisle with a small mezzanine area. We use three types of pillars here. The external pillars are 300 by 400 mm, the corner pillars 400 by 400 mm, and three pillars have a console. The foundations have two different sizes. Four corner foundations with dimension 1800 by 1800 and our foundations which are slightly smaller. Furthermore, we also have two joists on the consoles and 200 mm concrete ceiling. The roof structure will be completed by trusses. So it's a small project with 7 Revit families. To get the first data, we need a Dynamo script on a general data table. What we understand by the general data table? It is a spreadsheet listing all Revit families and their properties that you use in your work. We will call this Excel spreadsheet a large source table from now on. Here we are particularly interested in the parameters according to which the volume of the element is measured, volume in cubic meters, area in square meters, or length in meters. Equally important to us is the time and price quoted per unit of volume. In my table, all prices and times are fictitious. We have assumed, for example, that 1 cubic meter foundations is mounted in 20 minutes and the installation cost amount $20 per cubic meter. You can also specify here in which order the construction elements are planned or have to be manufactured, or as in our example, in which order the elements are mounted. For example, we know what the foundations assembled first, what is number 1, and the truss at the end. Therefore, the truss is number 7. Here you can also specify the product for each element. Our elements or arrays managed families, what are not used in this project, are also displayed here, which can be used in our project, for example. In my own project, I have used such a table with 6,500 families and their properties. Based on our large source table, I would now like to lead you through our model. We have a table and now we can start the first Dynamo script. We go to the Revit, tap Manage and start Dynamo. Dynamo is running now. I choose my first script. We are only 2 altogether. As it opens, I will briefly show you what we will be doing next. Step 1. Our script handles all assembly processes. In our case, every process coincides with one Revit family. The script chooses from our big source table only those families used in the project. The selected families of building elements are represented by a script in form of a new table. So Dynamo has loaded the first script by now. The script is divided in 3 modules. The first consists in importing data from our big source table. General properties of elements from this big source table I used as input for our Python program. In addition to that, our Python program receives as input data all families on their categories from the model. Python has exported our big source table and selected only those names and properties that are relevant in this project. We click on the Run button. The script is now running. The execution time of the script depends on the number of elements in your project. Usually it does not take longer than about 30 seconds. In the script we see the result, which is displayed in form of a directory. We can ignore this. Script itself exports this data to Excel, and we get a table 1. Table 1 is similar to our big source table. The table has become much smaller, and the table is now sorted according to order. Table 1 shows which parameters are used to calculate the volume, area or length. In addition to that, time and cost per unit from our big source table are also displayed. In which table we can assign an executive to each process. This can be, for example, a production plan or a system planner. In our case, as we are looking at the process in assembly phase, it will be an assembly company. I am now filling data into this column. We also change the order. We assume that in this project we can assemble the usual supports and supports with consoles in one and the same time interval, therefore number 2. And suppose, for example, that the beam and socle can be mounted parallel and we use the same number 4 for this assembly process. These works are carried out after the pillars assembly has been done. We save and close table 1. Now we will open the second script. As it opens, we will be taking a brief look at our second step. In this second step, our script takes over the finished table 1, which we have just completed. The script goes through all the elements in the model. If the name of Revit family matches, the script takes the volume parameter from the element and multiplies the value by the cost and time per unit of volume. So the script has opened. Here we can see almost the same models as in the first script, only this time our script uses it as input data with finished supplemented table 1. Here we also specify the start date of our assembly by filling in the duration of the process. Here we say, for example, that the assembly of the first element will start on 1st January 2020. The script takes the volume parameter of each element and multiplies the value in cubic meters by the cost and time per cubic meter from table 1. The Python code here looks more complicated. We are already about 300 code lines here. This data is exported to a new Excel spreadsheet. Let's execute the second script now. The script has run through and given us the file. Now we can see what is in our new table. This table is the enumeration of processes or elements having been assigned to respective volumes in each process. The beginning of assembly, as previously stated, is supposed to start on January 1st, 2020. This column lists all the product IDs that you can later check in Revit. How this works, I will show you later. This table can, in our case, be exported to Microsoft Project. This does not necessarily have to be Microsoft Project. The obtained data can also be exported to other management software, such as Scorer, Asana, Smartsheet, Monday.com, Hive, GAN-Pro or others. We are now going to import Table 2 into Microsoft Project. This is where Microsoft Project automatically retrieves our data. We ignore errors. After the importing process, Microsoft Project displays our data in form of a Gantt chart by default. Here we can add more columns with our attributes. Here we see the order in which the elements have to be mounted. First, of course, the foundations, then two types of pillars, then at the same time the socle and beams, and finally our trusses. The script has calculated that we will have finished assembling of all elements by July 2020. As an example, I will now be checking calculated volume for the foundations. We have 30 foundations measuring 1.5 by 1.5 and 0.5 meters. And 4 foundations with dimensions 1.8 by 1.8 and 0.7 meters. With the help of a calculator, we have now counted 23.697 cubic meter. If we compare value what the script has counted, we can see that everything is correct. 23.697 cubic meters. Here we can also see the IDs of elements for each process, and we can check the construction elements in the processes. For this we have to copy the IDs for the foundations. So in Revit we go to the tab Manage and then continue to select by ID. And here we insert IDs. When Revit chooses all these foundations based on the IDs in the model. So let's go over the main points one more time. We go through our model with big source table and obtain table 1, on which we made some modifications. When we started the second script, we went through model with a modified table 1 and obtained resulting table, which in our example we exported to a Microsoft project. What else can we do in Microsoft project? Let's zoom in on our diagram. Instead of assembly companies, again it is possible to add names of specific persons in the planning department. In this fictitious project, the field is empty. However, if you work with Microsoft products in your company, your colleagues' contacts will be displayed here. All the required information can also be presented in the form of Kanban. As is usual with Kanban, these processes can be transmitted into status in progress. For example, pillars without consoles and beams have now been finished. We therefore move the processes in the status done. On the diagram we can now see that the colors of the processes automatically changed, meaning these processes have been completed. What else can you do with bundle Revit on Dynamo? If we have a model in architectural planning, we can calculate planning times and planning costs in the planning phase. If we have a model in structural planning, we can calculate production times and production costs in the production phase. If we have a model in structural planning, we can, as I showed you today, also calculate assembly times and assembly costs during the construction phase. Dynamo has been conceived by open source community, and in combination with Revit proves to be infinitely large data analysis tool. In Dynamo we can create many different scripts that allow automation and optimization in planning and processing. Thanks to tools such as Dynamo, we can reduce routine work for everyone involved in the construction process many times over. Tools like these definitely reduce bureaucracy in construction processes in the future. If anyone has questions or needs this tool, please contact me via mail boyka@gmail.com. Thank you for your attention.